Hey guys, I'm going to put my reading skills to the test here. Um, no, I don't know what the repercussions of this will be. At first thought, I'm thinking tangible hologram, okay? But I don't know that that's what this will end up to be. UK discovery starts race to turn light into matter. Physicists have uncovered a surprisingly straightforward strategy for turning light into matter. The design, published in Nature Photonics, adapts technology used in fusion research and can be implemented at existing facilities in the UK. Several locations could now enter a race to convert photons into positrons and electrons for the very first time. This would prove an 80-year-old theory by Britt and Wheeler, who themselves thought physical proof was impossible. Now, according to researchers from Imperial College of London, that proof is within reach. Professor Stephen Rose and his PhD student, Oliver Pike, told the BBC it could happen within a year. With a good experimental team, it should be quite doable, said Mr. Pike. If the experiment comes to fruition, it will be the final piece in the puzzle that began in 1905 when Einstein accounted for the photoelectric effect with his model of light as a particle. Several other basic interactions between matter and light have been described and subsequently proved by experiment, including Dirac's 1930 proposal that an electron and its antimatter counterpart, a positron, could be annihilated upon collision to produce two photons. Brett and Wheeler's theoretical prediction of the reverse, that two photons could crash together and produce matter, a positron and an electron, could be difficult to observe. The reason this is very hard to see in the lab is that you need to throw an awful lot of photons together because the probability of any two of them in converting is very low, Professor Rose explained. Interconverting, whatever that word is, skip it. His team proposes gathering the vast number of very high energy photons by firing an intense beam of gamma rays into a further cloud of photons created within a tiny gold-lined cylinder. The cylinder is called a hologram, German for hollow space. See, I wasn't too far off with hologram. Kind of sounds like it. Because it contains a vacuum and is usually used in nuclear fusion research. The cloud of photons inside is made up of extraordinarily intense X-rays and is about as hot as the sun. Gamma rays, white, would be fired into a cloud of X-ray photons inside the hologram to produce positrons and electrons, red and blue. Hitting this very dense cloud of photons with the powerful gamma ray beam raises the probability of collision that will make matter and history. It's pretty amazing, really, said Mr. Pike. He says it took some time to realize the value of the scheme, which he and his two colleagues initially jotted down on a scrap of paper over several cups of coffee. For the first 12 hours or so, we didn't quite appreciate its magnitude, but their subsequent calculations show that the design, theoretically at least, has more than enough power to crack the challenge set by Brett and Wheeler in the 1930s. All the ingredients are there, agrees Sir Peter Knight. What a name. Professor at Imperial College, who was not involved in the research but describes it as a really clever idea. I think people will seriously start to have a crack at this, Professor Knight told BBC News, though he cautioned that there were a lot of things to get right when putting the design into practice. If it's done in a year, they've done bloody well. I think it might take a bit longer. Some healthy scientific competition may speed up the process. There are at least 3 facilities with the necessary equipment to test out the new proposal, including the Atomic Weapons Establishment in Oldham. The race to carry out and complete the experiment is on, said Mr. Pike. Okay, well, that's the entire article right there. 5 minutes. Peace out, guys. God bless.